Welcome to the Global WarWatch Network. Today we're diving into something that honestly feels straight out of science fiction but is rapidly becoming reality. Quantum tech. It's really no longer just theory, it's poised to completely transform the battlefield. We're talking unbreakable communications, next-gen cyber warfare. We'll explore how quantum is said to redefine military power. We've got some fascinating sources that shed light on this revolutionary shift. We'll give you a shortcut to understanding what it all means for military power and, well, global security. Okay, so let's maybe unpack this with a really recent and pretty intriguing example. It kind of sets the stage for why this future tech talk is so urgent now. Our sources point towards the South China Sea, a critical area for global trade, but also a constant flashpoint. We're talking Spratly and Paracel Islands, areas claimed by several nations, China and Taiwan included. And then you have countries like Brunei, the Philippines, Malaysia, Vietnam, all rejecting China's 9-line claims. It's complex, a real geopolitical hotspot.
Yeah.
Right. And here's where it gets really interesting, maybe even a bit alarming.
Our material highlights reports, and we should stress these aren't officially confirmed, but reports of an intense electronic warfare, or EW engagement. This was supposedly between the U.S. Navy and the Chinese PLA Navy near the Second Thomas Shoal. The reports, these are from Military Watch magazine, describe something like 12 hours where American warships faced an unprecedented crisis. Imagine, screens just full of static, a total loss of GPS signals. It apparently forced the fleet to actually withdraw. 12 hours of just electronic chaos at sea. Kind of humbling, right?
It is, and what's fascinating, maybe concerning, is what happened afterwards related to these reports. William Coulter, the commander of the U.S. Electronic Attack Squadron 136, well, he was unexpectedly relieved of his duties. The official line was loss of confidence. But our sources, the Eurasian Times specifically, suggest this might be tied to the Navy's alleged struggles against Chinese EW capabilities in that incident, which really raises a critical question, doesn't it? If these reports hold water, how much was a technology gap versus, say, human error under immense pressure?
That's a really key question.
Yeah.
Because it hints at maybe a deeper issue, right? The technological gap. And our sources from Military Watch magazine bring this up too, the age difference in the fleets. The PLA's main surface ships are, well, on average, decades newer than the American ones. Most of their fleet commissioned in the late 2010s.
Yeah, that's a stark contrast.
Compare that to the main U.S. surface combatant, the Arleigh Burke class. It's been around since 1991. So what does that age gap really mean for the U.S. electronic warfare edge? Seems like a potential built-in disadvantage?
It absolutely seems that way, and it's something the U.S. military is clearly aware of. If you connect the dots, materials from Breaking Defense show the U.S. military acknowledges it's losing that EW advantage it once had. Even with upgrades to platforms like the EA-18G Growler, this decline, well, it hinders operations against sophisticated adversaries. There's a quote from Air Force Major Gen David Snoddy saying, basically, we still have an edge, but it's smaller. We need to bring that margin back.
So they're reacting.
Definitely. They're creating specialized units, speeding up countermeasure updates. This whole situation, confirmed or not, is a wake-up call about conventional EW limits.
Okay, so if traditional EW is facing these new hurdles, where does quantum fit in? This feels like a major pivot. Our sources introduce quantum warfare, applying quantum principles to EW. But before we get into the how, what exactly is quantum warfare at its core?
Right, it's a fundamental shift. Quantum warfare, or QW, uses quantum technologies, QT, for military purposes. Intelligence, security, defense, across all domains. It really brings in new strategies, new doctrines, even new ethical questions we need to grapple with. It's built on quantum mechanics. The Joint Air Power Competence Center, JAPC, points out two revolutions here. Quantum 1.0 gave us things like nuclear fission, lasers, semiconductors. It exploited the statistical behavior of quantum systems.
The things we already rely on heavily.
Exactly. But now we're entering Quantum Revolution 2.0. This one exploits the really strange laws governing individual quantum systems, single electrons, atoms, molecules. The goal, to dramatically sharpen sensing, communication, and computing. It's about precision control at the quantum level.
Wow, that is a huge leap conceptually. So, manipulating individual particles. What specific capabilities does Quantum 2.0 bring to the actual battlefield? Can you give us a feel for these advanced applications?
Sure. There are several really key areas highlighted in the sources. First, enhanced sensing and detection. Quantum sensors could potentially detect and monitor a much broader range of the electromagnetic spectrum, and with far higher sensitivity than traditional systems.
So seeing things you couldn't see before.
Precisely. Detecting faint enemy communications, subtle radar signals, basically improving situational awareness dramatically. Second, there's wider bandwidth coverage. Traditional systems often scan frequencies sequentially, right?
Mm-hmm.
Quantum sensors might monitor a broad bandwidth instantly. This makes intercepting those fleeting low-power signals much more likely. Think of it as listening everywhere at once.
That's a massive advantage in a crowded, contested signal environment. What about analyzing what you detect?
Good point. That's third. Improved signal analysis. Quantum tech could lead to much more precise identification and characterization of enemy electronic systems. So not just detecting a signal, but quickly understanding exactly what it is, where it's from, maybe even its intent. That's critical for effective response. Fourth, and this one is still somewhat theoretical but very exciting, is quantum radar. This could offer big advantages. Higher resistance to noise and jamming, for instance. It might also be stealthier because it could operate using very low-intensity emissions.
It's harder for the enemy to even know they're being tracked.
Exactly. And potentially even better target identification, maybe telling decoys from real threats. Fifth, and this is huge, secure communications via quantum key distribution, or QKD. This aims to provide highly secure communication channels that are fundamentally resistant to eavesdropping based on the laws of physics.
Unbreakable codes.
Essentially, yes, for the key distribution part. Any attempts to intercept the key changes it, alerting the users. It secures the key, which then encrypts the data. It's a potential game changer for secure comms. Sixth, countermeasures against jamming. Quantum systems, due to their unique physics, might be inherently more resilient to traditional jamming and spoofing. Maintaining operation even when under electronic attack, and finally, looking further out, offensive capabilities. Quantum computing, when mature, could potentially break current encryption methods. That's a major long-term threat, though still years away from being practical, as our sources note.
That portfolio of capabilities sounds, well, almost revolutionary. Secure comms, stealth radar, better sensing. Is quantum the only focus now in EW innovation, though? Or are other things happening too?
Oh, absolutely not. Quantum is definitely a major focus for the future, but it's part of a broader push. Military plus aerospace electronics highlights several parallel developments. Cognitive EW is a big one right now, using AI and machine learning to make EW systems smarter, more adaptive, able to react automatically.
So, systems that learn on the fly.
Exactly. AI and ML are also enhancing testing capabilities, maybe reducing the burden on human operators. Then there's the push towards higher frequencies, more bandwidth, lower latency, but it comes with challenges like signals degrading faster. We're also seeing things like RF over fiber technology, using fiber optics to carry radio signals, protecting them from interference. And modular and adaptable systems MEMS designed to be reconfigured quickly to counter new threats.
So quantum complements these, it doesn't replace them.
Precisely. It's a holistic approach. Quantum adds powerful new tools, but development continues across the board.
That makes sense. It paints a picture of a layered strategy. And it's clear quantum is central to long-term planning for many advanced nations. Our sources mention the US, China, UK, Australia, India, Russia, Canada, France. All seem to be at the forefront, recognizing quantum's importance for future EW. It really feels like a global race is underway.
Okay, so given all this huge potential, what's the actual state of play? How mature are these technologies? Are quantum systems rolling out tomorrow, or is this still mostly lab work? And what about international bodies like NATO? Are they involved?
That's the million-dollar question, isn't it? Readiness. Our JPCC sources show NATO is definitely engaged. Very much so. Back in 2021, NATO defense ministers endorsed an emerging and disruptive technologies strategy. Quantum is a key part of that. They're promoting a coherent approach, studying QTs theoretically and experimentally across member states. There's even the Defense Innovation Accelerator for the North Atlantic, Diana, which has a specific branch looking at QTs.
So coordinating efforts. Trying to, yes. And NATO's Science and Technology Organization is doing studies, looking at trends out to 2040, trying to understand the implications. But, and this is a big but, it's crucial to understand that most quantum tech is still at low technology readiness levels, or TRLs. That means it's really difficult to accurately predict performance, capabilities, or deployment timelines. This leads to what's called the Collingridge dilemma. You can't really know a technology's impact until it's widely used.
But by then, it's too late to easily control or change it.
Exactly. It's a classic challenge for planners dealing with revolutionary tech. You have to invest to understand, but investment sets things in motion that are hard to start.
That's a really critical point for anyone trying to get a handle on this. So realistically then, when might we see these quantum systems moving from the lab into the field? And what are the main roadblocks?
Well, some quantum sensing tech is already being evaluated, showing promise. But the more advanced quantum EW systems, Quantumpedia suggests we're likely looking at the next 5 to 10 years for wider availability. The biggest challenge, it's really transitioning from the lab to the field, making these systems practical. We're talking about major engineering hurdles. Reducing size, weight, power needs the classic swap problem. These systems are often bulky, power-hungry, and delicate right now.
And expensive, I imagine.
Extremely expensive, yes. Cost is another huge factor. Getting them rugged enough for military use, affordable enough to deploy widely, that's the work ahead. So immense potential, yes, but many applications are still very much in R&D. The full impact is still some way off. It's definitely a marathon.
It certainly seems that way. It's clear the future of warfare is becoming incredibly complex, deeply tied to these advanced technologies, with quantum right at the cutting edge. The implications for national security, for military strategy, for the global balance of power, they're just immense. It forces a fundamental rethink of defense. And as we wrap up, it leaves you with a pretty stark thought, doesn't it? Will the next major conflict be decided not just by tanks and planes, but by who achieves quantum supremacy first? What happens to global stability when the very physics of information warfare changes? We want to thank you for joining us for this vital exploration into quantum warfare. We really hope this discussion has helped clarify how this tech could reshape military power and the road ahead. If you found this valuable, please do like, share, and subscribe to the Global WarWatch Network for more analyses like this one. We genuinely love to hear your thoughts too, so please share them in the comment section below. You can also join our community on social media. All the links are right there in the description. Until next time, stay informed and keep watching the global landscape.